Okay, I just want to take a minute to go over the notes for today in case you missed them or we were lagging or anything. Put this away. So we're talking about physical changes today, and physical changes are changes that are changes in matter that don't actually change what the matter is. So in a physical change, the matter identity stays the same. It does not change what it is. Those bricks are still bricks. Physical change involves a change in its size, shape, form, or state. So physical changes are things like rain to sleet, wood to sawdust. I take paper, shred it up. It's still paper, so you're just changing its size, its shape, its form. Something melting or boiling, that is a change of state. It's still the same material it is. Although the matter's identity stays the same, its properties might change. So whereas it's all H2O, it's still water, the properties are a little different because initially it's ice, which has a definite shape, definite volume, and when it becomes liquid, has a definite volume but not a definite shape. It takes the shape of its container. So its properties change, even though it is still water or H2O. When we chew food, that is a change in shape and size. We're making food smaller so our body can actually process it and digest it easier. Try not to be mesmerized by I believe it's a chinchilla, I think. But it's very hypnotizing. All right, I gotta move on. Matter undergoes a physical change when it goes from one state to another. So when you melt ice to water or change water to vapor, or the other way around, when water vapor becomes water and then freezes to ice, that is just a change of state, or sometimes it's called phase. Change in state involves a change in the energy of the particles. It happens by either adding thermal energy or taking away thermal energy. If we have ice and we add thermal energy, we move those particles faster and faster and faster to become a liquid. Fast enough, they become a gas. The other way, if we take away thermal energy, they're going to start to slow down. They're going to recondense back into liquid water. If we take even more thermal energy away, they can actually solidify into ice. The energy of particles changes when thermal energy. We're talking about thermal energy, which is basically just the energy of the movement of particles. Okay, adding energy can also be as adding or removing heat, which is a form of energy. And we'll talk about this when we do states of matter. When thermal energy is added to particles, they move faster and the temperature begins to increase. What is temperature? Temperature is how fast particles are moving. So by moving faster, it makes sense that temperature is also going to increase because that's what it's a measure of. When the particles move faster, they can overcome the attractive forces that hold them together. So when they're a solid and they're locked together, if they move fast enough, then they can break that bond to become a liquid. Moving faster, you can get them to become a gas. When enough energy is added to a solid for it to change to a liquid, we say that the material has reached its melting point. And chocolate's a fairly low melting point. You could do that probably in your hand. Things like gold has a low melting point, but you couldn't melt that in your hand. You would actually need flame to do that or some fire. When enough energy is added to a liquid for it to change to a gas, the liquid has reached its boiling point. So we keep moving those particles so fast they can actually break free of their bonds and become a gas. That's its boiling point. There are some materials that undergo a process called sublimation. Dry ice is one of these, and what dry ice does, it skips the step from a liquid, so it changes directly from a solid to a gas without first becoming a liquid. When we talk about states of matter, I will bring in dry ice and do some demonstrations for you, just because I love playing with dry ice. Any excuse to do it, but it doesn't go through the liquid stage. It goes right from a gas to a liquid, goes right from a solid to a gas, which is nice for coolers so you don't have all that water you're dealing with. Now, the reverse is true. If I remove thermal energy from particles, they start to slow down. And because, again, temperature is a measure of how fast particles are moving. If I slow them down, the temperature decreases. When particles move slower, now they are drawn closer together by those attractive forces between them. They start to move closer. Those gas particles get close enough, they get locked together kind of as a liquid. You slow them down even more. Now you've locked them even together as a solid or freeze them. When enough energy is removed from a gas for it to change to a liquid, we say that's condensation. On a warm summer day, you make a nice glass of iced tea, put it outside in a warm summer day, and you get like glass on the water on the outside. Well, that's not from the glass. That's from the air around the glass. The cold glass has cooled the water molecules so much that they've actually recondensed into a liquid. That is condensation. It's the same thing that happens when you shower. take a shower in hot water and that water hits that steam hits the cold mirror, it slows those particle downs and it recondenses into liquid water. When enough energy is removed from the liquid for it to change to a solid, we say that the substance has frozen. And we can do this with almost anything. We can freeze liquid nitrogen, but you have to get it really, 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 really cold, like negative 270 something Kelvin, like really bad, or 1 or 2 Kelvin, sorry. All right, now if a gas changes directly to a solid without first becoming a liquid, that's the reverse of sublimation. This process is called deposition. This is what you see when you, like, if you have frost on your windshield, like in the morning, if your parents go and they have frost on the windshield, or if you've ever seen trees that are just coated in ice. Well, that wasn't a liquid first. That basically, that water vapor changed right from a gaseous form right into a solid form, and that is deposition. Now, these are the processes that can reverse each other. Melting and freezing are reverse processes, as are condensation and boiling, and sublimation and deposition. For example, if you're buying candy on a warm summer day and you want to have it later, you don't want to leave it in your. I wouldn't leave it in my car because it's going to melt. But if it does melt, what do? I put it in the fridge or the freezer. It slows those molecules down and it re-solidifies. Condensation, sublimation can be reversed as well. Now, dissolving is not the phase change. Dissolving is actually those materials are being broken apart molecule by molecule. So it's not where they're just changing what state they're in. They're being broken apart or becoming a homogeneous mixture, but that's dissolving. Remember, we have the solute and solvent. In this case, the car is the solute. The nitric acid is the solvent. Some types of physical changes are reversible, such as when solid changes into a liquid and the liquid changes back to a solid. This is a process called ice wedging. You learn about in 8th grade. If you have cracks in your sidewalk that get bigger over time, what happens is they fill up with water. Water freezes. Now, water has a unique property that when it freezes, they crystallize, structure forms, and it actually expands. If you ever had a soda that you left out in the car and it's exploded on you, that's because the water has a property of it expands when it gets cold or freezes, which is unique when we talk about thermal energy and how that process happens. Conservation of mass. The law of conservation of mass basically says that matter cannot be created or destroyed. We can move it around. We cannot lose it. So the particles that are present before a physical change are also present after the physical change. So if you break a pencil, part of the pencil doesn't disappear. All those molecules are still there. They're just in 2 halves of a pencil. Mass is also the same before and after physical change. If I take a piece of paper and I find the mass of it, rip it in half and find the mass of both those halves, it's the identical. I haven't lost any molecules. I can't lose atoms. All right, those are the notes for the law of conservation of, physical changes. Remember, physical change is a change that the substance undergoes without changing what it actually is. Hope that helps. If not, please reach out to me and have a good rest of your day. Come on.